Hi, class. This lecture, we're taking a look at how clouds form. And fog obviously is one type of a cloud, so we'll also look at the different types of fog. But before we can begin, we've got to actually define what is the dew point, because that ultimately is the temperature where clouds are going to begin to form. So dew point is the critical temperature at which saturation is reached. Again, in the previous lecture, we took a look at when we cool the temperature down, there is, or when air goes up, you have adiabatic cooling. And that temperature is going to cause those little water molecules to slow down to the point where they're going to bump into each other and they're going to form little water droplets. So when does it get cold? Well, one, it gets cold at night. And so we see these tiny little droplets in the mornings when we're walking across the grass or we're looking at our cars. We can see those little water droplets that have come out of the air. You probably also notice it when you take a, I don't know, maybe I like Mountain Dew. So when you take a cold Mountain Dew out of the refrigerator, set it on the counter, and then there's all water on the outside. Well, that water didn't come from anywhere. That water came from the air. Now, when the actual substance is below the freezing point, like you see on this leaf here, you're not going to have what we call dew, you're going to have frost. So frost ultimately is just dew that is begin to condense onto a surface that is below freezing point. Okay, so let's also talk about some of the key examples of a cloud at the surface. So fog ultimately is just a cloud at the surface, and there are four general situations in which this takes place. And so I'll go through each one. You can see that they're here: radiation fog, advection fog, upslope or orographic fog, and evaporative fog. So I'll quickly explain them here, and then I'll go over a couple other examples. Now, radiation fog is the fog that we see in Southern California in the fall or in the spring. And the air that is cool, you see here, ultimately is pushed into our region by some type of a sea breeze. So that water not only is cool, or that air is not only cooler, but it also has tiny little water molecules in it. Once that air cools throughout the night, early in the next morning, tiny little water droplets now have turned into this pretty dense fog. Now then by 11 o'clock or so, the sun will come out and it'll warm it up and that fog will go away. So that is called radiation fog. We see it in our spring and in our fall, sometimes in the winter in Southern California. Another example is what we call advection fog. Advection fog, you have this cold water. For example, if you've ever gone to San Francisco, especially in the summertime, you have this really cold water called the California current in the bay, and then air that's somewhat warm blows over the top of it, and then that air is cooled and the fog ultimately is created. Upslope fog or even upslope clouds, air, when it runs into a mountain or a hill, is going to get forced upwards. That's going to cool that air, and you're going to have that cloud at the surface or just off to the side, and you can consider that upslope fog. The last example is the summertime fog, where you have this warm water and the air goes over top of it, and so you have a fog over top of the water. And it basically is evaporating tiny little droplets, and then those droplets right away condense and turn into that cloud at the surface. So those are our four types of fog. I'll go for a couple pictures, sort of in explanation. Now, this is the Central Valley of California, and you can see this whole region is foggy. They call that tulle fog because at night, water droplets sort of through dew come onto this plant called tulle, and then all of that extra water turns into this very dense fog. So that's an example of radiation fog that forms in the morning. So here's a great picture of advection fog. Again, you've got the Golden Gate Bridge. You can see the extent of this massive fog over top of that, again, really cold bay. So you can see that upslope fog is in areas where there are mountains. So you've got the coastal mountains of California, you've got coastal mountains in Oregon and Washington State. You can see here in the Appalachian Mountains and here as well in the Sierra Mountains. So days that actually are the foggiest ultimately are the result of upslope fog. The last example you can see here is of a fisherman, and again, the fog is not as dense, but ultimately you've got evaporation of the water creating this light fog that you see here. So in addition to the different types of fog, I'm going to go through 4 different ways clouds form through different processes on Earth. Probably the most common is that during the day, a section of the land surface is going to heat up greater than the other area. And as that air rises, it cools and it's going to turn into a cloud. This particular cloud is called a cumulus cloud. And in Southern California in the afternoons, you can easily see these when there is moisture available. Again, just to reiterate the fact of air that moves up along a mountain is going to turn into a fog at the surface, or it's going to turn into a mountain. That again is called orographic lifting. So all these types of examples to how clouds form are the result of air moving upwards. Another example, and we'll go into more detail on this one, but when you have a front, it's going to collide the air and the air is going to move up. And so this is called frontal wedging or air lifting along a frontal boundary. And then our last example would be that of what is called convergence. And Florida is a perfect example, and that's why Florida has more thunderstorms than anywhere else in the United States. Sea breeze from the eastern side and the western side come together to create the thunderstorms on top of Florida. So that is it for today. Thank you so much for watching, and I'll talk to you soon.